Question from October-November 2012, paper 11, number 13. So here is a description of this diagram. A mass of 2 kilograms rests on a frictionless surface. It's attached to a 1 kilograms mass by a light, thin string which passes over a frictionless pulley. The 1 kilograms mass is released and it accelerates downward. What is the speed of the 2 kilograms mass as the 1 kilograms mass hits the floor, having fallen a distance of 0.5 meter? So let me start with the free body diagram. So here is the force that represents the weight of the 1 kilogram mass, which is 1 times 9.81 meters per second square. Here is the weight of the 2 kilograms mass, which is 2 times 9.81 meters per second square. The other forces involved in this diagram are the normal force, because this box is on a surface, in contact with a surface. This box does not have a normal force, but here we have a string. So this is the tension on this string, labeled with letter T. So then this tension is equal at any point on this string. So right here we have the same tension but in opposite direction. Next, we need to look at the direction of the system. The problem says that once the 1 kilogram is released, so it's going to move in this direction. Here, the direction that this box is going to move over the frictional surface, and as passed through the pulley, is going downward. So make the direction of this motion as positive acceleration. So now let's go to our step-by-step substitution. The sum of all forces acting in the direction of motion is equal to the total mass of the system times acceleration. So here we have, as all forces acting in this direction here, we have the weight of this 1 kilograms mass, and then we have this tension, and we have this tension. Notice that the weight of this box that is on the surface and its normal force do not affect the motion in this direction because they are perpendicular. Okay, so now we have here, start with the weight of this box because is downward, same direction of the motion of the system, minus, this is the opposite direction of the system, and then plus T, which is the same direction of the system, is equal to the total mass of the system, which is 2 plus 1 kilograms, times the acceleration of the system. So, doing the substitution and the calculation, the acceleration here is 3.27 meters per second square. The question is asking the speed this box of 2 kilograms is moving. So because both boxes, they are attached through this string, so we can deduce that both boxes, they are going to move with the same speed and same acceleration. And we can use information from what we have to fill this table, the motion table. So the initial velocity before the box of 1 kilogram is released, the initial velocity is 0. The final velocity we don't know. The distance here is 0.50 and the acceleration is 3.27 meters per second. Time is not relevant. So do we have a motion equation that we can use this information and calculate the final velocity? Yes. So this is the equation. So doing the substitutions, we have VI of this box is 0 and 2 times A, 3.27, and D is this height. So the final velocity is 1.8 meters per second, or speed. So here is the correct option A.